Hello, welcome to lecture 5. Today I am going to talk about circle and the circle will be covered in two parts. So today the first part will be on tangent and secant. This is mathematics for class 10, chapter 10 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. So today before we go to tangent and secant, let us again revisit what we did in our last trigonometric lecture where here I have drawn a circle, okay, a quarter of a circle with radius 1, unit radius, r equal to 1, and we had defined earlier that from if any point on this circle, if you draw a tangent line, so the distance from this point C to cut where it cuts the x-axis is the tan theta, and the distance from C to where it cuts the y-axis is the cot theta, and distance from A to this intersecting point where the tangent cuts is the sec theta, and distance A to point H is the cosec theta. So please go through my last two lectures and we have discussed this in detail. Here I have drawn similar thing, this trigonometric function in a different way. I have just taken the tangential point at on x-axis and one tangential point on the y-axis at point F. So here also you can define, like here I have said that sine theta is BC, that is opposite side by hypotenuse, AC is 1. So BC is sine theta. Cos theta is your adjacent side by hypotenuse, AB by BC. So this is AB. And tan theta here I am writing here as, because this unit is 1. So I am trying to exploit this one. So I will take tan theta is opposite by adjacent. So I want to make this one. So I take not here, but I take up to here. So if I take the opposite side will be this length. So tan theta will be your ED by 1, that is ED by AD. So this distance ED, if I extend this line here, this tangential line will intersect this line here. So this distance where it intersects this line and x-axis is the tan theta. So similarly cot theta, suppose say this is theta, this will be 90 minus theta, and here you have 90 degree because I am taking a tangential, this line is perpendicular. So this is 90, this is 90, so 90 plus 90, 180 minus theta you have. So this remaining angle has to be minus here because this theta and this theta will get cancelled. 90 plus 90, 180, sum of all internal angle of a triangle should be 180. So now this angle is also theta, so I write cot theta is equal to adjacent by opposite. So adjacent is your FG here by FA. So I am trying to exploit this unit radius. So here again FA is 1. So cot theta is your FG. And similarly sec theta is your 1 by cos theta. Cos theta is, here cos theta is will be adjacent side AD by hypotenuse. This is AE. Here I have written. I am exploiting this again. This is AD is equal to 1. So this will go up. So sec theta is your AE. So this distance will be AE. And similarly cosec theta will be your cosec theta is opposite side, that is AF by hypotenuse. Hypotenuse is here AG. So AF is 1. I am exploiting this one. So AG will go up. So your cosec theta is AG. So this way also you can write. And here what we did last time, that is this distance from point C to point I is tan theta. That is tan theta is, suppose this is theta, this is opposite side by adjacent side of this theta is this one. So this is your AC. AC is 1, CI. So this CI is your tan theta. So similarly cot theta, that this is your theta here. Again you can use the same argument, 90 minus theta, this is 90. So this has to be theta, this theta and this theta again. So this is again theta. So cot theta is HC by AC. So AC is 1. So it is HC. So this is your cot theta. So similarly cosec theta is equal to 1 by sin theta. So for this sin theta is, this is your opposite side by AH. This is AC by H. AC is 1. So it becomes AH. So similarly sec theta is your 1 by cosec theta, and cosec theta is equal to adjacent by hypotenuse. Adjacent side is 1 AC and this is your hypotenuse AI. So sec theta is equal to AI. So here I am discussing this because you see here tangent is a line. Most of the line is outside the circle and only touching at one point. And secant is the line is inside the circle and cutting at one point here and it is going up to infinity. And similarly it will cut in the opposite direction. So secant will have 2 points where it will touch the circle. So to repeat, tangent will touch at only one point and most of the line is outside, and secant will touch or intersect circle at 2 points, at one point here, another point here, and some portion of the line is inside the circle. Okay, that's why this is just to picturize why that these lines are called tangential line and secant line, just to introduce you from this trigonometric thing. And suppose you have for any radius, if it is not 1, then of course sine theta is BC, that is opposite side BC by R, if this R is not 1, and you can write this distance BC as R sine theta. Similarly do for the rest, and most of the time you will see it will cut, it will cancel numerator and denominator, and this will hold always true. Okay, so to repeat again, from this point here, when it cuts E, this is tangent. This is from point B to D, this is opposite side sine. In this adjacent side or projection here, you can draw here, that is the cosine, and from this center point where it intersects the tangent is called the secant, and from this intersect this center point to here is the cosecant, and from this point B where it intersects the y-axis is the cotangent. Okay, now we will use this figure to show you that if you take this coordinate system, the theta can be anywhere between 0 to 360. So if theta angle is in this first quadrant, then you can see here that all these quantities sine, this is your x is positive, y is positive, x is negative, y is negative. So you can see here that all these quantities are positive. But if suppose angle is greater than this 90 plus some theta, this is 90 degree, then you will only have in this quadrant, you will have only this y-axis is positive, but x-axis is negative. So sine theta and 1 by sine theta will be positive, rest everything will become negative. And similarly here, when you have in the third quadrant, you will have only tan theta and cot theta positive, because sine theta is also negative, cos theta is also negative. So numerator denominator minus will cancel, so tan theta and cot theta, but rest will be all negative. And similarly in quadrant 4, you will have again this cos theta is positive, this the projection on the x-axis will be positive. So since cos theta is positive, 1 by cos theta will also be positive. And just to remember this, you just remember this all silver teacups. So first quadrant is all, then second quadrant is silver, this is tea cup. What it means? All are positive. Here sine is positive, so cosec of course has to be positive. Tangent is positive, so cot is also positive. And here cos is positive, so sec is also positive. So if you remember this all silver teacup, so you know which quantities are positive and which are negative. So to elaborate little further, as we have seen here, all these quantities are positive. Here also with this description, the second description which we did in the previous slide, these are all positive here. So these are also positive. So if this angle comes to the second quadrant, you can see here that cos is negative, this is negative, only sine is positive here. So similarly, once cos is positive, negative, cot is also negative, others all will be negative except sine and cosec. Okay, now let us discuss secant line and a tangent line. So if you have a circle here, this is a line not touching, but as it touches here, okay, perpendicular to the radius, any point it can be, this is called a tangent. And if I bring this line inside, it will intercept at 2 points. This will be secant, okay, which we have discussed earlier. Tangent will be always touching a line. Most of the portion of the line will be outside, and secant some portions are inside, which we have discussed. So I had to discuss the previous two graphs because otherwise it is difficult to understand what tangent and secant means, why these are called tangent and why it is called secant. Okay, and as we mentioned that a tangent touches only a single point, and a line from origin to this point, it will always be perpendicular. Here we have shown that this is origin and this is say point P, and this is the shortest distance, and any other distance that crossing the line will be larger than OP. And similarly, second, we discussed that if you draw a line passing through the circle, it will intersect at 2 points, and this is secant. And by now I hope you have understood why this is called secant and this is called tangent. Okay, now we discuss what happens if there are two secant lines intersect. Either it can intersect inside the circle or it can intersect outside the circle. So suppose this is an intersecting point, then this arc, if I move this point down, this arc length will increase. Here it is increasing. And when I move down, when it is inside the circle, it will also reduce. But as soon as I go outside the circle and I again increase, so this arc will again increase. So here actually there is a relation between this arc length and this angle, and we are going to discuss this in next few slides, which may be outside the syllabus of class 10, but I feel it is important to understand what really secant and tangent mean. Okay, and if this is a tangent here, then you know this angle we will show in next few slides that whatever the angle here you get it, you see this 60. So this angle plus this angle always has to be plus 180 degree. So 60 plus 120 is any angle. If it is 45, then 180 minus 45 will be this degree. Okay. So this we will show it in the next few slides. So if we consider two lines, either secant or a tangent, if there are two secants or one tangent and one secant are drawn, there are four ways the two lines can be placed on a circle. In each case, arc, angles and line segment have special relationship and they are as follows. So this is what is saying that either this intersect, these are the secant, either they intersect outside or they intersect inside. These are two secants. Or you can have one tangent and one secant. So tangent means it has to be on the circle and secant will pass through 2 points. Or you can have one tangent here and 1 secant and it intersects outside. Here it intersects on the line. Here it is outside. So these are the four ways these two lines can interact. So now there are some relation between this arc, angles and line segment, and here I have written for this case, that is AE into AB is equal to AD into AC, and measure angle, this angle here is related to this measure of this arc. Okay, and arc I have writing here, this arc BC, I am writing an arc on top of it, or I can write here M also, but sometime I will write and sometime I will not, but this means it's an arc. And we have seen in class 9 that this angle here, suppose BOC, and suppose there is a point here and say it is some O primes and BO prime C, this BO prime C will be half the angle of BOC. So please go through class 9 lectures and try to understand this. And here measure angle, this angle now it is outside, so it is this arc minus this arc length divided by 2 is the measure angle. This we will prove all this so in the next few slides. And similarly for case 2 we can show that EC into ED is equal to AE into EB, and measure angle AED or measure angle CEB, they should be same because they are opposite angle here. And this we can show that this is measure arc AD or measure of arc CB by 2, and similarly this angle here and this angle should also be same, so I have written same, and that is measure of arc AC plus measure of arc DB divided by 2. We will prove all this. And here also this line is here, this is a segment and tangent, so angle subtended here, this BAD, angle BAD is half of the measure angle arc AB by 2, and this measure angle, this BAE, this one, okay, this is a bigger arc and I call it ACB, okay, to distinguish from here. If I write just AB, I do not know which, so I have written here C here, so this measure of arc ACB by 2. And similarly for case 4, if you have a segment here and on tangent here, so I can write AC into BC is equal to DC square, okay, this is the relation which we will prove. And measure angle BCD, this is BCD is nothing but measure angle of this one minus, when it is going outside it will be always minus. See here it is minus, it is going outside, and when the intersection is inside it is plus. So just remember this. So this will be minus here. So this arc minus this arc divided by 2 is the measure of angle BC. Okay, now we will discuss all the 4 cases. Case number 1 is 2 secants intersecting outside the circle. What it means, that 2 secants are there and they are intersecting at point A outside the circle. And to prove what are the relation between the segment, length of these segments, and also to show what is the relation between this measure angle EAB with respect to this arc, we will find out. So what we do to finding out this, first we will find out what are the relation between the segments. So I joined from point B to D a chord, okay, a line, and another line from point E to C, and I make 2 triangles. One triangle is your AEC and another triangle is your ADB, and these are the 2 triangles, and this is the common arc subtended by angle C and angle B. So these 2 angles are same because the arc is common to both, and this angle is common to both the triangles. So from angle I can say that triangle ADB is equal to ACB. So if these 2 triangles are similar, triangle ADB and AEC. Then I can write using the corresponding part of similar triangle, that is AE, this is for triangle 1, divided by AD, this is for the triangle 2, this side. This is for triangle 1 and this is for triangle 2. So similarly for triangle 1, this side AC by AB, and if you do cross multiplication, you will get the relation between the segments. Now we also know the measure of an arc is equal to the measure of its corresponding central angle. What does it mean? This measure of this arc is equal to the measure of its corresponding central angle. This is the central angle BOC. So measure of angle BOC is equal to the measure of arc BC. And suppose if you have a point here, then you know that the measure of this angle, suppose B, this is O prime if I call it, B O prime say C, this measure of this angle will be half of measure of angle BOC. So please go through class 9 lectures and the derivation and proof is given there. So we will use this, that measure of BOC, angle BOC is arc BC, and BEC, this is point here, so this will be BC by 2. As we have proved in class 9 that measure of angle BEC is half of measure of angle BOC. Okay, so here I write this BEC is half of BOC, measure of angle BOC by 2. So measure of angle BOC is BC, so it is BC by 2. And measure of angle ECD, this is ECD, this is the red line, red arc here, is ED by 2. So now exterior angle, I want to know this angle, so I use a trick that I know this exterior angle is sum of opposite in two internal angles, this angle plus this angle. So once I know this relation, then I can find out the relation is angle BEC is equal to measure of angle ECD, this angle plus this angle EAD. So now I want to know this one, so I take it to the left hand side and I will get measure of angle EAD is equal to, you substitute here, you will get BC by 2 minus ED by 2, and 2 is common, so I write. So here I can say that measure of angle EAD is nothing but arc, this measure of arc BC minus measure of arc ED divided by 2 will give me the measure of angle EAD. So here I have drawn something. This is minor arc if the arc length is less than 180 degree, and this is a major arc for arc length greater than 180 degree. Okay, now we discuss case 2, 2 secants intersecting inside a circle. So here you have 2 secants here, they are intersecting at point E, and we have to find the relation between this arc and angle and relation between the segments. Similar problem we had done in class 9 with respect to chords. So please go through my lectures of class 9. That will be helpful to you to understand better all these problems, because class 10 is simply an extension of class 9. So I request you all to go through all the lectures of class 9. So here what I do is this measure angle ABD, this is measure angle ABD is measure of arc AD by 2, because we know that measure of angle AOD is equal to measure of arc AD, and measure of angle say ABD is half the measure of angle AOD. That you please go through class 9 lectures and see it. And so if it is so, then measure of angle ABD will be measure of arc AD by 2. So this is what I have written here. And similarly measure of angle CDB, this is CDB, will be half of arc BC or CB by 2 divided by 2. If the angle would have been here, then it is simply CB. But since the angle is from this end, so it will be CB by 2. So now if we consider this triangle, so the exterior angle of this triangle is AED. So you extend this line here, and this is the exterior angle. This exterior angle is equal to opposite internal angle or interior angle, angle D plus angle B. So here I have written there measure of angle AED is equal to measure of angle ABD and measure of angle CDB. So these two angles, okay. Angle B which is in the center and angle D which is here, okay. And measure of angle ABD, this measure of angle ABD is the measure of arc AD by 2, and measure of angle CDB, this is CDB, is a measure of arc CB divided by 2, which we have written here, substitute here. So you have measure of angle AED is equal to, I have written measure of angle CB because these are the opposite vertical angles, and that is equal to AD, if I substitute here, AD by 2 plus CB by 2, 2 is common. And similarly measure of angle AEC and angle DEB is this measure of arc AC plus measure of arc DB by 2. And now to find the relation between the segments, so I use the similarity condition of similar triangles. So I draw two triangles here. So I join from point C to B, and from A to D I join two segments here, and the angle, this is the arc, red one. So angle subtended by angle C is measure of arc BD, and here angle subtended by angle A is also same thing. So these two angle has to be same, and these are the opposite vertical angle, so they have to be same. So from angle also we can say that these two triangle are similar. And the third angle is also same because they subtend this green arc here, and this one is also subtending this CBA is subtending this green arc. So either angle or angle. From that similarity condition I can say triangle AED is similar to triangle CEB. Because as I said, angle C is equal to angle A because of arc BD, and angle B is equal to angle D. This is B and this D is because of arc AC. So these two triangles are similar. So I can again use the similarity condition, that is ED, this from green to blue, by EB, okay, green to blue, is equal to AE, AE is this one, red to blue, by EC, red to blue. So this is the similarity condition, and I now cross multiply and I get the relation between the segments, that is ED into EC is equal to AE into EB. Okay, now case 3, a secant and a tangent intersect on a circle. That is, this is a secant and a tangent intersect on a circle. So now from the last two cases, now it should be very clear that this angle BAD, okay, is equal to half of measure of arc AB by 2, and similarly measure of angle BAE is half the measure of arc ACB by 2. And since there is no segment, only one segment is involved, so there is no relation between the segments, and this tangent line is going to infinity. This D and all is not a finite segment. This E can be anywhere on this line. These are very simple. Measure of angle AOB. AOB is the measure of arc AB, and measure of angle CAB is half the measure of angle arc CB by 2. Measure of arc AB by measure of arc BC is 180 degree because half is a semicircle. So this measure of angle BAD is nothing but this 90, this is 90 degree, this is a perpendicular to the tangent, minus measure of angle CAB. So measure of angle CAB I have written here, and measure of angle CAB is what? This is measure of arc CB by 2, which I have written here. And since measure of angle BAD is this 90 degree minus measure of angle CAB, so I can write here measure of angle CAB is nothing but measure of angle BC by 2, and now I can write here 2 into 90 is 180, so 180 minus this measure of angle BC divided by 2 is measure of arc AB. 180 minus this CB will be AB, okay, this arc. So here I have written here. So just go through it, and similarly you can show this measure of angle BAE. Okay, now the last case number 4, a secant and a tangent intersect outside a circle. So what it means, this secant, this is very similar to the case 1. In case 1 there were two secant which were intersecting outside. So here one tangent and one secant, and this is a tangent, and I draw a triangle here. I join a line from D to A, it becomes a triangle, and this angle 2, this is the exterior angle of this triangle, and we know that exterior angle of a triangle is sum of two opposite internal angles, that is angle A plus angle 1, and we have to find what this angle 1 is, that is angle BCD. So what is the measure angle BCD? This is nothing but the measure of arc AED, this AED, minus the measure of arc DB or BD is same thing by 2. So as I had said, if it is outside, it will be, there will be a minus sign. So it is very similar to the second formula. So how do you prove it? So it is very simple to prove. This measure of angle DAB, this is measure of angle DAB, is this arc BD by 2 because it is in the other side of the circle. If it would have been here, then this 2 will not be there. DOB, measure of angle DOB will be simply BD. So this, please go back and forth and try to understand it. Okay, so exterior angle measure of angle 2 is equal to measure of angle 1 plus measure of angle DAB, okay, which I have written here. So what is measure of angle 2? We have seen in our case number 3 or previous one that it is half of measure of arc AED by 2. So I write here measure of angle 2. Just go to the previous case and see this. Measure of arc AED by 2 is equal to measure of, this is 1, measure of angle 1 is measure of angle BCD, which I have written here, and measure of angle DAB is measure of arc dB by 2. So I have just substituted here, and now I just rearrange it. So measure of angle BCD, I take it here, is nothing but measure of arc AED minus measure of arc BD by 2. 2 is common here. So here there are many segments. This AB, BC and DC, these are the segments. So they should also have some relation. So what I do is I draw this, I join this from A to D and from D to B. So I have two triangles here, this small triangle and a big triangle. And this arc is common, you can see here. So the angle here, and for this also, for small triangle, this arc is common. So what is the angle, measure of angle, this red one, this red dot will be half of measure of arc dB by 2. And similarly, this one will also be measure of arc dB by 2. Okay. Just go to the previous case and see where tangent is intersecting, tangent and secants are intersecting on the circle. So here I can see that these two triangle is similar because this angle and this angle, red and green, and there is this triangle also have this red and green because this angle and these angles are same and this is a common angle. So from angle criteria, I can say that triangle ADC, this triangle is similar to triangle DBC. So I start with red, then I go here and I come to green. There also I start with red, come here and go to green. So from angle and also C is common, we can say these two triangles are similar. Since these two triangles are similar, then I can definitely write that AC, this is your hypotenuse of this triangle AC, and by DC for the small triangle, AC by DC. AC is for the big triangle and DC is for the small triangle. So again, if I say the base of the big triangle is DC and the base of the small triangle is BC, then DC by BC. So these are hypotenuse, these are the bases. So this is from the corresponding part of similar triangle. So hypotenuse by hypotenuse, base by base, or height by height. Okay, this is the similarity condition. So from this similarity condition, I cross multiply and I get AC into BC is equal to DC square. So this is the relation between the segments. Okay, now we will see few examples based on the 4 cases we have studied. So here the first example is, suppose you have two secants which are intersecting, and it is, the question is what is the angle 1 here. So it is very simple, which we have said the measure of arc this plus measure of arc this. So 52 plus 40 is 92, divided by 2 is 46. So the measure of angle, this is 46 and this also will be 46, and this angle will be 180 minus 46. Similarly, this angle will be 180 minus. So if any problem like this is given, you have to solve like this. Here is asking what is the measure of arc GH. This symbol, as I said, is arc GH. What is the measure of this arc GH? So given is here is the measure of arc is 28 degree and this angle is 45. So here what you have to add here, so 62 plus 28 is 90, divided by 2 is 45. So this answer will be 60. So I am just directly putting it, you please solve it yourself. Next, what is the measure of angle 3? This is the measure of angle 3. We have discussed that measure of angle 3 is the measure of arc, this arc, big arc, which is 220 degree, divided by 2. So it is 110 degree. Next one is what is the measure of arc RT? This is the arc RT. If this arc would have been there, they would have put one more letter here, but that means this is. So this is angle is 74. So definitely this measure of angle, this angle should be, this arc should be double of this. So 74 times 2, or 148 divided by 2 is 74. So the answer is 148. Then what is the measure of angle 5 here? So here again still it is inside. When it is inside, I had told you, you have to add it, and when this intersection point goes outside, you have to subtract the two arcs. So here again we add it. This is 130 plus 90. So 130 plus 90 is how much? 220. So measure of this angle will be 220 divided by 2, this is 110. So remaining is 70. So this angle will be, angle 5 will be 70. So here. Now what is the measure of angle 6? So if this is 160, so this will be 200 because total circle is 360. So measure, this angle will be half of the measure of arc. This is 200 divided by 2 is 100. So measure of angle 6 is 100. Now what is the measure of angle 1? Now this intersection point has gone out. So we have to subtract this arc 80 degree minus 40 degree is 40. And this arc minus this arc divided by 2. So 40 divided by 2 is 20. So measure of angle 1 is 20. Now next one, what is the measure of angle 2? Again similar thing. This arc is 160. This is 80. So if you subtract it, it will be 80. So measure of angle will be 80 divided by 2. Okay. This arc minus this arc divided by 2. That's 80 by 2 is 40. Now what is the measure of angle 3 here? Okay. This is 2 tangential points. So measure of angle 3 is, this is given 220. So then remaining one will be your 360 minus 220 is 140. And so 220 minus 140 is 80 and 80 divided by 2 is 40. So this angle is 40. Okay, go through those all cases and find the formula from there. Whenever the intersection is outside, this arc minus this arc. This arc is given, so this is the remaining portion. So you can find out 360 minus 220. So this arc minus this arc divided by 2 gives you answer 3. Now in this is asking what is the measure of arc G. Okay, this angle is given. So this arc minus this arc. So 70, if suppose it is 30, 70 minus 30 is 40, divided by 2 is 20. So this is, so you can definitely find out. So you please find out. Now what is the arc, measure of arc LN? This is the LN and this angle is given as 50. So I can draw a perpendicular line from here. So this measure of this angle plus this angle should be 180. So this has to be 130. So if this is 130, so this is the measure of arc. Okay, LN is 130 degree because measure of arc is equal to measure of angle corresponding to this center point. Okay, now what is the measure of angle B? Is very similar to this. So this arc is 100. So from here to here is 210 plus 80, 290. So remaining is 70. So 100 minus 70 is 30. 30 divided by 2 is 15. So this is what you can get. So please go through those formulas and go through this. These are very simple. So as I did it orally, you really don't require pen and paper for this. Now let me say a few more properties of tangents to a circle. That is, the length of two tangents from an external point are equal. So what I mean, if this is an external point, so AC is equal to BC. This I can prove using right angle hypotenuse side criteria. That is, both this triangle and this triangle have one right angle. Then these two sides are equal. And this is the hypotenuse, they are also equal. So this is called the RHS criteria. So this triangle OAC is congruent to triangle OBC. And since they are congruent, so this AC equal to BC, because of the corresponding part of congruent triangle, we can say that all angles and sides are same. So again, the angles will also be same. This angle will be this angle and this angle will be this. And the tangent drawn from an external point to a circle are equally inclined to the line joining the point to the center of a circle. So from this point, they are equally inclined. This is also another property. If two tangents are drawn, these two angles will be equal, which we have seen here also. Tangent to a circle. A tangent to a circle is a line that intersects the circle at only one point. This is, we define it. There is only one tangent at a point of a circle. So for given point, there is only one tangent because only one line will be perpendicular. If you cannot have two lines, if you bend it, then it is not a perpendicular. The tangent to a circle is a special case of secant when the two end point of its corresponding chord coincide. So if you have a secant here, so you move towards this, you will have this 2 point of the secant will finally coincide when it becomes a tangent. Okay, now example 2, two tangents TP and TQ are drawn to a circle with center O. So these are the tangent TP and TQ from an external point T. Prove that angle this PTQ is double the angle OPQ. Okay, so this angle, if this is theta, so this is theta by 2. So how do we prove it? Here, since TP is equal to TQ, so this triangle TPQ is an isosceles because these sides are equal sides of a triangle. So if two sides of a triangle are equal, then it is an isosceles triangle. And if it is an isosceles triangle, then this angle will be beta. So similarly, this angle also will be same beta. Please go through lectures of class 9. All this has been discussed very elaborately. So angle TPQ, this is angle TPQ and TQP, they are beta. And I can write that sum of all the internal angle should be 180. So 2 beta plus 80 is 180. So I can get from here, I just rearrange it and I will get beta is equal to 90 minus theta by 2. So if it is 90 minus theta by 2, but this angle, this TP and this has to be 90 degree. So definitely this angle, this is 90 minus theta by 2 and plus theta by 2, then this angle, if you add it, it will be 90 degree. So here I have shown these things, just go through it. So beta plus angle OPQ is 90 degree. So OPQ is 90 degree minus beta, that is equal to theta by 2. Now example 3, PQ is a chord of length 8 centimeter. This PQ is a chord of length 8 centimeter of a circle with radius 5. This is radius 5. Find the length TP. This is the length TP. Okay, this tangential length TP. So I have been given this. If I draw a line from center to this. We have shown that these two triangles are congruent in our previous slide. So this will bisect it. So this distance will be 4 centimeter. This 5 centimeter radius is given. So 4 square plus 3 square, that is 16 plus 9 square root of that gives. So this should be 3. Okay, now this angle TPR, this is TPR plus this RPO, they will become 90 degree. This angle plus this angle is 90 degree, and also similarly TPR plus PTR is also 90 because this is 90. So this angle plus this angle has to be 90. This angle TPR plus PTR is also 90. Okay, so that means angle RPO is equal to angle PTR, that is RPO is this RPO is equal to angle, this angle RPO is equal to angle PTR, this angle. So here I have written, and that means suppose this one angle and this angle are equal and then 90 degree these are. So there are two angles. From angle I can say that triangle TRP, this triangle is similar to triangle PRO. Okay, PRO by angle similarity. So now I take the corresponding part of the similar triangle. So say suppose this is like an hypotenuse and say this is a bigger length. So I call it this height, and this is smaller, so I call it a base. So similarly here I can call this as base, this as height, and this is hypotenuse. Okay, so similar part means now here I have written PR. PR, this is the base of the big triangle, divided by RO, this is the base of the small triangle, is equal to TP. TP is the hypotenuse here, and PO is the hypotenuse of the small triangle. Big triangle by small, big triangle by small. And so PR is, we found it is 4 and RO is 3. So 4 by 3, and TP we do not know, we have to find, and PO is given as, this is PO is 5 centimeter, which is the radius. So now I can find TP, I just take 5 here, 20 by 3. So TP is 20 by 3. There's another way you can find out by using Pythagoras theorem. So here I am using the Pythagoras theorem. So this we have shown earlier is 4 because half of that, and you take 4 square plus 3 square, square root of it gives you square root of 25 is 5. So here I use this x square is equal to y square plus 16. This is your hypotenuse, and say this is the distance y, and this is this square plus this square should give me x square. So x square is equal to y square plus 16, and also I use this triangle here. This is your hypotenuse of this big triangle. So here x square plus 5 square is y plus 3 the whole square. So now I use these two simultaneous equation. How do I solve it? I expand this one. X square is equal to this 5 square will go this side as minus 25. So it is y square plus 6y, and 3 square is 9. So I write here, and I subtract here. Okay, x square and x square get cancelled, this also get cancelled. So I have minus 6y because this is I am subtracting this, so minus 6y, and 9 minus 25 is minus 16. So minus of minus become plus, so 16 plus 16 is 30. So I can write y is equal to 32 by 6, that is 16 by 3. So I get the value of y from here, but we have still not got this distance which the question asks, find the value of x. So now I can write x square is equal to, I substitute this here 16 by 3, this y plus 16 is equal to, I can just take a common 16 by 9. So I take 16 by 9 common. So this is 16 square by 9. So 16 I have to multiply. There's an extra 9 here, 9. So this becomes 16. So now I can add 16 into 25 by 9. So x square is 16 into 25 by 9. So x will be square root of 16 is 4 into 5 divided by 9, that is 25. So we found the value of x by using this Pythagoras theorem. This is the second way of doing it. So as I said, there is no unique way of doing geometry. You can use different protocol, but it has to be logical. Okay, now we will discuss exercise 10.2 of your chapter. Exercise 10.1 is very trivial. It's simply some fill in the blanks and some statements. So we will not discuss that. So kindly go through the textbook. Okay, exercise 1. From a point Q, the length of a tangent to a circle is 24. So suppose this is a point Q. The length of a tangent from the circle is 24, and the distance Q from the center is 25, and this distance is say 25. This is Q, say. The radius of the circle is, so we have to find this radius. So we use a Pythagoras theorem, that is this side square plus this side square is hypotenuse square. So here 25 centimeter is the hypotenuse. So I write this hypotenuse square is r square plus 24 square. So I get this 24 square on the right hand side. So r square is 25 square minus 24 square, that is 49. 9. So r is equal to 7. So kindly expand this and check it. Exercise 2. In figure, if TP and TQ are two tangents, if this TP and TQ are two tangents to a circle with a center at O, so that this POQ is 110, then find angle PTQ is equal to this PTQ if it is 110. So this will be 70 because sum of these two opposite angles should be 180. So 110 plus 70. So answer is 70 here. Exercise 3. If tangent PA and PB from a point P, this is PA and PB from a point P to a circle with center O are inclined to each other at angle 80. Okay, this is angle 80. Then PO is equal to, is very simple. If this is 80, so this angle will be 100. So this is half. So POA is 50 degrees. Prove that the tangent drawn at the end of a diameter of a circle are parallel. So we know that tangents are perpendicular to this radius and this is the diameter. And if you draw a tangent here, all this distance will be same. So they are parallel to each other. Prove that the perpendicular at a point of contact to the tangent to a circle passes to the center. So anywhere if you do it, the perpendicular line will pass to the center. So here you see that if the line is here, the shortest distance will be, this is say the point of contact, and this, the length here will be greater than the radius. So this is the shortest where it is touching the tangent. So that will be the radius and it will pass through the center. Now exercise 6. The length of a tangent from point A at a distance 5 centimeter from the center of the circle is 4 centimeter. So that means this from point A to here is say 4 centimeter and from center it is 5 centimeter. And find the radius of the circle. What is the radius of the circle? So this square plus this square is equal to this square. So I have written here similar thing. You just rearrange it. So radius is, this is your 5 square. So that is 25. And this is your 4 square. That is 16. So square root of 25 minus 16. That is 3 centimeter. Okay. 25 minus 16 is 9. So square root of 9 is 3 centimeter. These are very simple. Exercise 7. Two concentric circle of radius 5 centimeter and 3 centimeter. This is the concentric circle. This distance is 5 centimeter radius and 3 centimeter. Find the length of the chord of the larger circle. This is a chord of a larger circle which touches the smaller circle. So what is the length? Suppose this is 5 is given, this is 3. So this will be 4 because 4 square plus 3 square, square root of it will give me 5. So if this is 4 here, so this will be the length of the chord will be 8 centimeter. Exercise 8. A quadrilateral ABCD, here I have written ABCD, is drawn to circumscribe the circle. This is circumscribing a circle. See figure. Prove that AB, this is AB plus CD is equal to AD plus CB. Okay, RB. So how do you prove this? Tangent from the same point are equal, which we have seen. So this length SD and DR are same. RC is equal to CQ and BQ is equal to PB and SA is equal to AP. So this I can write here. Here I have written AP is equal to AS. And adding all this AP plus PB plus DR plus RC, the left hand side, equal to add all of them, then you get something like this. I have added all AP plus PB plus DR plus RC is equal to this. And now I can see that AP plus PB, okay, is nothing but AB and DR plus RC is nothing but DC, okay, or CD is equal to AS plus DS. AS plus DS is AD and then BQ plus CQ is BC. So we have proved this one. Exercise 9 in figure 10.13. This is a figure. XY and X prime Y prime are two parallel tangent to a circle with a center O and another tangent AB. This is another tangent AB touching at point C. Intersect XY at A and XY prime at point B. Prove that angle AOB, this angle AOB is 90 degrees. So this is very simple. Tangent from A, this is from tangent from A. This is AP is equal to AC. Similarly, BC is equal to BQ. So here I have written BC from point B. Now you can see here there are two triangles OPA and OCA and these are congruent triangle because from side. This side and this side is same, okay, length. This side and this side is also of same length and this is a common side. So from side congruent rule OPA is equal to OCA. So this angle 1, okay, will be equal to angle 2 because this is the same side here. You see this side. So this angle will be belongs to the same side and opposite to this perpendicular, and this is also opposite to this perpendicular. So angle 1 is equal to angle 2. So similarly you can show that this triangle OCB and OQB, these two triangles, they are also congruent, and here also using similar argument angle 3 and angle 4 are same. So now we know that angle 1 plus angle 2 plus angle 3 plus this angle 4, this has to be 180, and we know that this is 1 and 2 are same, 3 and 4 are same. So I write here twice of angle 2, and because angle 1 is equal to angle 2 and and angle 4 is equal to angle 3. So twice of angle 2 plus angle 3 is 180 degree. So angle 2 plus angle 3 will be 180 by 2. So that is equal to 90 degree. Exercise 10. Prove that the angle between the two tangents, this angle between the two tangents, this is y, drawn from the external point, this is the external point, to a circle is supplementary. So this angle is supplementary to the angle subtended by the line segment joining the point of contact at the center. This line joining, so this angle and this angle is supplementary. So is similarly sum of all the internal angle, this angle plus this angle plus this, for a quadrilateral should be 360 degree. So this angle and this angle, we know 90 plus 90 is 180. So angle x plus y has to be 180 to make it 360. So angle x plus y is 180. Exercise 11. Prove that the parallelogram circumscribing a circle is a rhombus. So what is the definition of rhombus? That it should be parallel, opposite side be parallel, and all the side has to be equal. Okay, this length DC, AB, AD and CB all have to be same. So how do you prove that? We know that parallelogram is AB is parallel to DC and AD is parallel to BC, and for rhombus all this side has to be equal. So again we use the same trick which we used earlier. The tangent from the same point are equal, that is this distance SD is equal to DR and RC is equal to CQ, AS is equal to AP and PB is equal to BQ. This is what we have written, PB equal to BQ. Okay, DR equal to DR is equal to DS. So same thing what we have written, just go through it and adding all the left hand side, this left hand side and right hand side, I get something like this. AP plus PB plus DR plus RC I write here, AS plus BQ plus DS CQ I write here, and then again I will get that AP plus PB, this is AP plus PB is equal to AB, and DR plus RC, so this is DR plus RC will be DC, okay, or CD, and again here AS, this is your AS plus SD, okay, or DS is AD, this length, and BQ plus CQ is your BC. And since it is a parallelogram, AB is equal to DC and AD is equal to BC, I get twice AB is equal to twice BC because AD is equal to BC. So similarly twice CD also I can show, I can again write here AB is equal to DC, so twice CD is equal to twice AD, and so on. I can show this sort of thing and I can prove that AB equal to BC is equal to CD. So this is a rhombus. Now exercise 12. A triangle ABC is drawn to circumscribe a circle of radius 4 centimeter. So this ABC, this triangle is drawn and this is been this circle is been circumscribed by this triangle and the radius of the circle is 4 centimeter, such that the segment BD and DC into which BC divides by a point of contact, this D, are of length 8 centimeter and 6 centimeter. Okay, this BD is 8 centimeter, BD and DC, this is 6 centimeter DC respectively. Find, see figure, so find the side AB. So the question is find the side AB and AC. This one is given 8 centimeter plus 6 centimeter, that is 14 centimeter is given. So again I can use the same condition, that is from point C, if the tangent is there, if this is 6 centimeter, this will also be 6 centimeter. So I have written in a red here, and if this is 8 centimeter then BC is also 8 centimeter, but I do not know what is this AB. I write it as X. So let us find area of triangle ABC. This is ABC, the area of triangle ABC is area of these three triangles. There are three triangles. This is one triangle, then there is a second triangle, and there is a third triangle. Okay, that is COB, then COA, and then is your AOB. Okay, AOB. This is a triangle. So how do you find the area of a triangle? That is half times the base, the 6 plus 8 is 14 base, times the height is 4 centimeter. For all of them will be 4 centimeter if you draw perpendicular. So I can write half times 4 is the height for all of them, A plus B plus C, this total length I am calling it A, then B and then C, and A is nothing but 6 plus 8, that is 14, and B is 6 plus X, and C is 8 plus X. So here I have written 14, 8 plus X plus 6 plus X. So I can simplify this and I get 56 plus 4X. So 4 I can keep out common. So that is 4 into X is 4X and 4 into 14 is 50. So this is the area of the triangle ABC, but still I do not know what X is. So I will try to use another formula to derive the area of a triangle, which we have studied in class 9. This is called the Heron's formula, where Heron's formula says that this S, which is a semi-perimeter, perimeter means length of all the sides A plus B plus C, C, and semi I'm calling it because it's divided by 2. So A plus B plus C divided by 2 means there are 2, 6, 2, 8 twice of x, okay, the length of the perimeter, divided by 2. So that means 6 plus 8 is 14 plus x. So I get here 14 plus x. If I'm going fast, please pause and go back and read this. An area of triangle ABC using Heron's formula is square root of s. S is this quantity here times s minus a times s minus b times s minus c. Okay, s is 14 plus x, so I write here 14 plus x, and s minus a, okay, this, so 14 plus x minus 14 is x. So similarly s minus b, so here s minus b is 14 plus x minus 6 minus x. So this minus minus gets cancelled, so you will have, and 14 minus 6 is 8. And similarly s minus c, s is 14 plus x minus 8 is 6, and plus x and minus x get cancelled, so only 6 remains. So now I can write the square root of 8 into 6 is 48x times 14 plus x, the square root of. Now I can equate these two here. So I have one x here and another, so I have two formula, and now if I equate it, I should able to find out the value of x. So how do I equate it? I square this 48x times 14 plus x is equal to, since I have squared this, I square this also. 4 square is 16 times x plus 14 the whole square. So here I have written here, this is here 16 x plus 14 the whole square. This I'm squaring this, and once I square this one, the square root will go 48x times 14 plus x. So now I just bring this side, I take x plus 14 comma, you just go through, you pause and see. So you will get these factors, and anyway we have studied in class 9 factorization in detail. So now you are in 10th standard, so you please go back to your 9th standard class lectures, which is there in the playlist in my channel. And so you will have the solution will be x. To make this 0, either x is minus 14, so if it is 0 times any number is 0, so x is minus 14, which is unnatural. Your length is never negative. Or x is equal to, this is 14 minus 2x, because x minus 3x is minus 2x. So here x is 14, this is minus 2x, so 14 by 2 is 7, so x is equal to 7 here. So since x cannot be negative, so x is equal to 7 is the solution. So this will be x. So 6 centimeter plus 7 centimeter, 8 centimeter plus 7 centimeter. Now exercise 13, prove that the opposite side of a quadrilateral, so this is a quadrilateral A, B, C, D, these are the opposite side, this DC and AB, these are the opposite side of a quadrilateral circumscribing a circle. So substance supplementary angle at the center of the circle, that means this angle plus this angle is 180. These are this opposite side, and this angle substance is opposite side. Okay, so if I add both this angle, that is angle 2 plus 3 plus 7 plus 6, this angle will be 180. If this is 180, this also angle will be 180. So total this circular thing is 360. So how do you prove it? We have discussed earlier in the problem that from this point, this length and this length is same, and this is the radius, and this is a common. So these two triangles are congruent. So angle 1 is equal to angle 2. Similarly, angle 3 is equal to angle 4. Similarly, angle 5 is equal to angle 6, and angle 7 is equal to angle 8. So I write it here, and I know that all this angle together forms 360 degree, as I said earlier. So now I group them as 1, 2, 3, 4 plus 5, 6, 7, 8. And since this angle 1 is equal to angle 2, so I will again have twice of angle 2 plus twice of angle 3, and here twice of angle 7 plus twice of angle 6. So 5 is equal to 6. That is equal to 360 degree. So 2 I take common, so then this angle 2 plus angle 3 and angle 7 plus angle 6 will be 180. So this, because 360 divided by 2, because this 2 both common will come here. So this two angle forms a supplementary angle. Similarly, these two angle 4 plus 5 together and angle 1 plus 8 for the angle which sustain this side and this opposite side. So if you add them again, you will get the same one. From here only you can show it. Okay, thank you, and we have completed the chapter on circle of your textbook, and see you in next lecture.